A packet can look suspicious and still be completely innocent. Before opening a capture, get written authorization from the actual owner. Record the interface, traffic owners, purpose, protocol scope, time window, storage, viewers, and deletion date. Do not collect unrelated traffic. This exercise uses only an owned, disposable lab with synthetic.test names, documentation IP addresses, and no credentials, cookies, tokens, PII, or secrets. Our capture is a deterministic 62-packet file made inside a network-isolated Kali 2026.3 container with T-Shark 4.6.6. The client is 192.0.2.10, DNS is 0.53, and the web server is 198.51.100.20. For a future live lab, list interfaces with Shark D, choose only the owned adapter, keep non-promiscuous mode, and stop after 30 seconds. The capture filter UDP port 53 or TCP port 80 decides what gets retained. The display filter DNS or HTTP only changes what you see, every packet stays in the file. Load the supplied PCAP and enter DNS. We have 12 DNS frames, 6 queries and 6 responses. Now use dns.flags.response == 1 and then dns.flags.recode == 3. For next domain responses remain. Pair each response with its query using the transaction ID plus dns.response_to. dns.time gives delays of 31, 44, 59, and 73 milliseconds. That is the packet fact, for failed names in a tiny synthetic window. It could be a typo loop or stale configuration. It could also justify checking for automated probing, but the packets alone do not prove that. One more filter, dns.qry.name.len greater than 40, finds a 51-character name in frames 11 and 12. Length is notable, not proof of tunneling. Clear the filter and enter http.request. 5 requests appear. Frame 16 is get/status, and its http.response_ and field points to frame 18, status 200. 3 later gets 4/missing1, -2, and -3 point to 404 responses in frames 28, 38, and 48. The response side http.request_ and field brings us back to each request. All 5 measured http.time values are 60 milliseconds. Repeated misses may be a broken client, test automation, a stale link, or enumeration. Check the web server and application logs before choosing among them. The filter http.response.code greater than or equal to 400 shows exactly those 3 404s. Now correlate across protocols. The successful DNS transaction for portal.lab.test resolves to the synthetic web server. Then TCP stream 0 carries get/status to that address and returns 200. Streams 1 through 3 carry the missing paths and return 404. Write the chain down, frame and relative time, source and destination, DNS ID or TCP stream, request frame, response frame, status, and measured delay. Keep 2 columns beside the facts, benign alternatives and a labeled hypothesis. Wireshark's own expert information is only a hint, so a colored warning is the start of investigation, not the verdict. Frame 56 is the privacy lesson. The filter http.request.method == post reveals /telemetry in the harmless synthetic fields device =lab sensor in state =OK. Frame 58 returns 202. Real plaintext HTTP could expose hostnames, paths, form fields, cookies, or authorization data, so do not capture or show real secrets. With HTTPS, those HTTP methods, paths, headers, bodies, and statuses are generally hidden unless authorized TLS secrets are available. Missing plaintext fields do not mean missing activity. In this beginner lab, do not collect TLS keys. Preserve the original capture read-only and analyze a copy. Record the authorization reference, file name and SHA-256, UTC window, time zone, interface, capture filter, tool version, frame or stream IDs, direct facts, alternatives, hypothesis, corroboration still needed, owner, action, and disposition. Capinfos reports packet counts, timestamps, duration, and hashes. Remediate only after corroboration, fix stale names or broken paths, stop retry loops, confirm asset and process ownership, enforce HTTPS, protect the capture, then repeat the smallest authorized window and verify the pattern changed. The workflow is simple: authorize, capture narrowly, filter without deleting evidence, correlate transactions, separate facts from hypotheses, remediate, and verify. Copy the Wireshark checklist from the description, subscribe for more defensive Kali labs, and explore the WSQ cybersecurity courses below.